Welcome. In this video, I wanted to talk about problem number 25, which is probably the hardest one in this section, or maybe rather the last one, rather say the last one. And I wanted to do it live so I could probably, so you could see my process of how I analyze a problem, and in the process I hope you learn something. So we're going to read it first. So we're told that in figure 7-34, a block of cheese with a mass of 0.25 kilograms lies on the floor of an elevator cab with a mass of 900 kilograms. So the cab has a mass of 900 kilograms, while the cheese has 0.25 kilograms. But now we're told that the elevator cab is being pulled upward by a cable. The cable pulls this cab through a distance of 2.4 meters. So it's going upward, it's being pulled through a distance of 2.4 meters. And then it gets pulled another 10.5 meters. So this motion of pulling the cab up is performed in two sections. The first part is 2.4 meters, and the second part is 10.5 meters. Okay, and then through the distance one, the first distance, we're told that if the normal force on the block of cheese, I guess, yes, the block of cheese from the floor, has a constant magnitude of 3 newtons, how much work is done on the cab by the force from the cable? Okay, so this might be a little bit cryptic. So notice we're told that the normal force on the cheese, that is the force with which the floor pushes the cheese up. So let's say this is the base of the elevator cab, and here's the cheese. We're told that the force with which the floor pushes the cheese up is 3.00 newtons, and we're told it's a constant 3.0 newtons. Okay, what we're asked to find, however, is the work done by the cable. So the cable is the one that's pulling the cab upward. So we could call this the tension on the cable, or whatever we want to call that force that the cable applies on the cab. The point is, we need to find the work done by this force. Let's designate it as Ft, that is force, tension force. So what we're interested in is to find the work done by the tension, or the force, let me say F sub t. Since the normal force here is constant, we can conclude that this object will have, the cab will have a constant acceleration also. Because let's think about it. How many other forces beside the cable, the force from the cable or the tension from the cable, what other forces are present acting on the cab? Well, the only other force is the force of gravity. And we know that's constant. So the sum of constant forces is going to result into a constant net force. And a constant net force is going to give rise to a constant acceleration. So by that, we have enough to deduce that the work done by tension is going to be given by this formula, that is the magnitude of the tension force times the displacement in question, which in this case, the first part of the trip is d1, times cosine of the angle between the tension force and the displacement vector. Well, the tension will be pulling the cab upward, and the cab will be displaced upward, at least for now. Actually, the whole trip it's being pulled upward. So we know that phi is going to be 0 because the tension force is upward, and so is the displacement, d1. So we know that phi is going to be 0. We do have the displacement 1, that's going to be 2.4. The only thing missing is this force. So now we need to go find this force. We need to find the magnitude of the tension force. Now we got to consider what other means, what other information do we have available at our disposal that will allow us to find the tension force? Well, consider what is common between between the cab and the cheese. If the cab is moving up, the cheese will also be moving up. If the cab moves up at a certain acceleration, the cheese will also move at the same acceleration. So we need to consider what can we use, what information can we use in order to determine the tension force. And here, based on the problem, I would begin with the acceleration because it's common to both the cheese and the cab. So let's go ahead and draw the free body diagram of the cab. So suppose here's our cab. Two forces are acting on it. It's going to be the tension force, and it's going to be the force of gravity. And I'm going to say this is the cab. Maybe I should say cab, CB. That's for cab. And then the gravitational force for CB. Now, since we're told that the cab is moving up, we know that there must be some acceleration. So since we don't know what it is exactly, we're going to have a placeholder for that. We cannot assume it's zero until we have enough information. But at the moment, we could just say, well, the acceleration here is going to be due to the tension force minus Fg of the cab. This is going to be the mass of the cab plus the cheese. And that's going to be our acceleration in the y direction. Notice here I am saying that the mass that the cable is accelerating is actually it's that of the cheese and the cab, because the cable pulls the whole system. According to the cable, it needs to support both the 900 kilograms of the cab together with the 0.5 kilograms of the cheese. So that's what's important here. So then we have this AY as an unknown, but we know it's going to be common to the cab and also to the cheese. So it's easy for us to find what the force of gravity of the force of gravity on the cab. That's very easy. We have the mass, and we know the gravitational acceleration. That's 9.8. We know the mass of the cab together with the cheese. We could figure that out. We are looking for this tension force, but notice AY is also unknown. So if we could go find what AY is, the acceleration along the y direction, we would be able to plug it back in here and determine what the tension force is going to be. So then let's change our view and go check out the cheese. Suppose we were to draw the free body diagram of the cheese now. The cheese, we were told, is being pushed at a constant force upward, a normal force of 3 newtons. But because the cheese's mass, we know it's also being attracted toward the center of the earth by the force of gravity. So we're going to have Fg sub c for cheese. Now, these two forces, as far as the cheese is concerned, are the ones, or rather, the sum of these two forces is going to be responsible for accelerating the cheese. So that means we're going to have Fn minus Fg sub c. This is going to be the mass of the cheese times the acceleration, Ay. Now, it should be clear that this Ay is exactly the same as this one. Otherwise, the cheese and the cab could not be in contact, or the cheese could not be on the surface or could not be on the floor of the cab. They must have the same acceleration. Now notice, when it comes to the cheese, we have enough info to determine what A sub y is. We know what Fn is, that's 3 newtons. And minus, we know that when the mass of the cheese is 0.25 multiply by 9.81. That's the force of gravity, or the force at which gravity attracts the cheese toward the center of the earth. And then we know again the mass of the cheese, it's 0.25, and then we can find what a sub y is. Once we find what a sub y in this problem here, we can therefore substitute it back in there and determine what the tension force is going to be. And once we have the tension force, we would be in a very good position to find what the work done by this tension force is. Right now, I'm going to use representative figures. Let's say the acceleration we found was equal to a meters per second squared. We would need to take this a and substitute it in here in order to determine what the tension is. And let's suppose once we've done all the numbers, the tension is equal to B newtons. Now, once we have the tension, we could go to determine the work done, and specifically here, the work done will be the magnitude of B times the magnitude of the first displacement, because that's what we're asked about. We were asked to find the work done by the cable, whereas it moves the cab over the first distance. Over here, the magnitude of our displacement is 2.4. So this is going to be 2.4 meters times cosine of the angle between the tension force and the displacement. And I think we've argued enough to say that the angle between those is going to be 0 degrees, and therefore we will be able to find that the work done is going to be 2.4 times the magnitude of tension. And of course, I haven't done the numbers in order to save time, but you should be able to have, I think this should help you to figure out how to go about this problem. And for brevity, I will stop the video here. See you in the next one.